Hello and welcome to Solved Papers channel. I am Godfrey. In this video I'm solving a Cambridge Air 2 physics. This is a communication topic from November 2019 exam series. I encourage you to consider revision topic-wise. Read a given topic and attempt the questions when the content of that topic is fresh in your mind. This way you will get the most out of the topic. This is a sure way of getting your A star if that's what you're looking for. Before we begin, if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon. This way you will be notified every time I upload a new video. I wish we get started. Question number one. This is where question number one was set in. From this you can see that question number one was set in paper 4.1, and this was question number 5 in paper 4.1 of November 2019 exam series. So that could be of use if you need to refer. A section of a coaxial cable is shown in Fig 5.1. This is Fig 5.1 right here. You can see there is copper wire, there is insulation, copper braid, and a plastic covering. Suggest two functions of the copper braid. Two functions for the copper braid. One, for every circuit, of course, for any information to flow through the copper wire, of course, it has to flow through electrical signal. And for any electrical signal to flow, of course, there has to be a complete circuit. So the copper braid here serves as the return for the signal to complete the circuit. So this provides return for the signal. That's what we write. Of course, in simple term is to complete the circuit for that, so that the signal may be transmitted. The other function is that this copper braid here shields the inner copper wire from interference, and so we say that it shields the signal that is being transmitted through the copper wire from noise and crosstalk. That's why it is usually secure to send signal through the coaxial cable. It cannot easily be tapped because of that copper braid there. Part 2, suggest one application of the coaxial cable for the transmission of electrical signal. The obvious one is connecting an area. Sorry, this is an area, the TV area, to a television set. This is the easiest. Many other applications, but this is the simplest. Just get that. Part B, the constant noise power in a transmission cable is 7.6 microwatt. The minimum acceptable signal to noise ratio is 32 decibels. Calculate the minimum acceptable signal power P min in the cable. Of course, you need now to write the signal to noise ratio, which is usually log 10. 10 times log 10, then signal here is the numerator, and the noise is a denominator right there. Okay, brackets there. You do good brackets. So then, of course, we are given signal to noise ratio, which is 32 decibels. Of course, write that here. 32 decibels is equals to 10 log signal, which you are supposed to calculate. We are supposed to calculate the acceptable signal power, P min. So the minimum power that is acceptable, divided by noise. Noise you are given here. The constant noise power in a transmission cable is this. So given 7.6 times 10 raised to power minus 6, given right there. So you can divide both sides by 10. Divide both sides by 10. When you divide both sides by 10, you get 3.2. 3.2 is equals to log P min over 7.6 times 10 raised to power 6 minus 6. 10 raised to power minus 6. Therefore, you take logarithm both sides. What you're going to get is 10 raised to power 3.2 is equals to P min, this is min, divided by 7.6 times 10 raised to power minus 6. Okay. Then, of course, we multiply both sides to make, let me just write this on here. You make P min subject. P min subject is 10, 3 raised to power 3.2 times 7.6 times 10 raised to power minus 6. When you calculate nicely with your calculator, you get 0.012 watts. So that is the minimum acceptable power in the cable, 0.012. So if the power of the signal seems to drop below this, then before it drops, there need to be a booster to strengthen the signal. Otherwise, you'll not transmit what you want to transmit to the other side. Okay, let me say that you can get this same question that I'm solving here at this site, saltpepper.co.uk. I encourage you to practice working out these questions yourself. That way you will be building your muscle, and it will be good for you. Part 2, the input power of the signal to the transmission cable is 2.6 watts. The attenuation per unit length of the cable is 6.3 decibels per kilometer. Use your answer in one to determine the maximum uninterrupted length L of the cable which the signal may be transmitted. Of course, before the booster is put in place. So of course we know that attenuation per unit length is equals to log 10 log 10 power in over power out, and all of this divided by length. Okay, so then we are given the attenuation per unit length. We are given the whole of this is 63 sorry, not 63, 6.3 decibels per unit kilometer. So is equals to 10 log power in. We had told here it is 2.6 watts, and power out is what we had gotten in part 1, which is this one here, 0.012. so 0.012, and of course we want to find length, so divide by L, the length. That's how we are supposed to find. We need to get length, that is, what is the maximum length, L. Right, so of course you're going to make L subject, so L is equals to 10 log 2.6 over 0.012 divide by 6.3. Of course, you can use your calculator, and when you do correct calculations, you'll get something like 3.7076 kilometers, approximately 3.7 kilometers. That is the distance. That is the maximum distance before you get the power booster. Okay, but as I said, you can get these questions that I'm solving here right now from softpapers.co.uk. The site that I'm talking about is this one, if I may just point that to you. This website I'm talking about, Soft Papers. You've come, of course, to A level. There's maths, physics, and chemistry. Go to physics, and 2019 A2. That is what I'm solving right now. I may go there, and the paper that I'm doing right now is, of course, you'll find that there is both. There are topicals for both November and June. Of course, there are some which is solved there to show you an example. The paper that we are solving right now is November communication topic, so you can click here to download it. Of course, you can get all these other topics for November, also for June. Of course, to get all of them, you need to click here. They are in a zip folder. If I click right here, I'll come right here. This is a zip folder, and you'll find that there are papers for 2019, 2018, 2017, and 2016. Of course, you can get all these papers. I encourage you to get all of these papers. Of course, this is November 2019. November 2019. Of course, you'll find there is physics, chemistry, and mathematics. And you need to click here. It's only £10. You can ask your parents to help you with this, with acquiring these papers. Of course, you can also get for June, same 2019 June, and okay, you can get as many as you can. And of course, you can also get all of them at a discount right here, because for both June and November, you can get them at a discount right there for physics and for other subjects. Let me also mention that I also do online tuitions. If you need assistance, you can also get me from this site, spacademy.co.uk. The site that I'm talking about is this site here, Soft Papers Academy. We call it SP Academy. Of course, you can take time and explore the site. Right here, you can get to know, you can get the guide here, a step-by-step guide for your dashboard functionalities. You can also watch this video to get familiar with our online classes. if you are a tutor, you can of course get this, the guide right here. And we do ICT, mathematics, physics, and biology, and chemistry. If you need help in those areas, you can get in touch with us. We will be able to help you get your A star. Of course, when you make up your mind, I need you to register. Just click here. You need to register and create your own account. You'll have your own dashboard. Then we'll send an email to you, so you give us a correct email. You need the email to activate your account so that you may be able to sign in. Once signed into your account, then you can find a tutor. You can click here to get a tutor, and then you start learning. Hopefully, I'll be seeing you in my online tuition classes. Okay, then we will help each other. Great. Let's continue with number 2. Number 2 was set from paper 4-2, October, November. This was question number 6. So the variation with time of the displacement of an amplitude modulated AM wave is shown. This is amplitude modulated. You know, there is also frequency modulated, and of course the displacement time graph. Of course, the displacement time graph is right there. Okay. This sinusoidal for information signal has a frequency of 10 kilohertz. The sinusoidal information signal has a frequency of 10 kilohertz. We are to determine the frequency of the carrier wave. We are not be given the signal of the carrier wave. We are given the signal of the. We've not been given the frequency of the carrier wave. We'll be given the frequency of the signal, which is 10 kilohertz, which is supposed to be carried by the carrier wave. So to determine the frequency of the carrier wave, you come to the graph and determine what is the frequency of the what is the period of the carrier wave. Of course, you can see from 0 to 10, from 0 here to 10 microseconds. We have how many complete waves? We have 1, 2. We have 2 complete waves. So time period, or what we call period, period is equals to 5 microseconds from here to here. That is one period. So since now we have found the period of the carrier wave, then of course you can say that every 10 microseconds, there are two periods. Okay, we have established that. So this means that a period is equals to 5 microsecond, and therefore we know that frequency is equals to 1 over period, and therefore this will be 1 divided by 5 times 10 raised to power minus 6, and you'll find, use your calculator nicely, you'll find that this is 200,000 hertz. So the frequency of the carrier wave is 2.0 times 10 raised to power 5 hertz. You can give it also in underline form, but standard form is 1, 2, 3, 4, 5, 2.0 times 10 raised to power 5 hertz. That's the frequency of the carrier wave right there. On the axis of fig 6.2, this fig 6.2, sketch the frequency spectrum of the modulated wave. This is a amplitude modulated wave, so we need to sketch that, and we know that the frequency of the carrier wave, as you have found out, it is 200,000 hertz, this one right here, Therefore, we know that the frequency of the signal, it was given, the frequency of the signal was given right here. It is 10 kilohertz. 10 kilohertz is 10,000 hertz. So this is a 10,000 hertz. So we want to find the bandwidth. The bandwidth is equals to 2 times the frequency of the signal, and 2 times the frequency of the signal is going to be 2 times 10,000, and it would be the bandwidth be 20,000 hertz. Therefore, we know it's going to be the frequency of the carrier wave plus 10,000. The frequency of the carrier wave plus 10,000. This will give us the upper limit, which is 210,000 hertz. The lower limit will be Fc minus 10,000 hertz. This will be 190,000 hertz. So then, of course, from 210 to 290, if you find the difference, you'll get 20,000 hertz. Therefore, I can plot here. I can plot somewhere here. Let me plot here. There's 1, 2, 3, 4. Okay, let me call this one Fc. Frequency of the carrier wave. Frequency of the carrier wave is here. Can start from here. Try to draw as straight line as possible. It's not straight. For there. Then the frequency for Fc plus F signal. Can plot it here. And then Fc minus F signal. Plot it here. So then, of course, I've sketched the frequency spectrum of the modulated wave. It's from 190 kilohertz to 210 kilohertz. Bandwidth is to 20,000 hertz. That's it, guys, for this topic of communication. Only 2 questions was set on November on communication. One was on paper 4.1, the other one was on paper 4.2. As you can see here, was on paper 4.2. So get the topic of communication from June 2019, November 2018, June 2018, and going backward, and make sure you revise and get comfortable with this topic. Once you meet a topic on communication, just relax and get it done. All the best as you prepare for your 2021 and beyond exams. Hope to see you in my next videos. Cheers.